welcome to Mathspellbook. I'm your host Peter, and basically we are going to do something a little different today. What music do we got today? We're just using the typical music that we've always been using. But how are you doing, Black Sensation Black? What's the best part of your day so far? Hey, Sasha, how's it going? So I have a big announcement today, guys. So today I just recently realized that I got the email from Twitch. So Mathspellbook is now a Twitch affiliate. So, you know, I want to thank you guys so much for actually getting us up to this point. You know, you guys are the basically the real support that got us to this I guess status is a word. Like, I'm not really good at giving basically what I'm trying to say is that I want to thank you guys so much for actually getting us to this point to getting to affiliate status. So yeah, it's like a lot. Plus chat, right? Yeah, it's our effort to spread. Yeah, so we managed to get I haven't done the affiliate process yet for this channel, because like I do have affiliate on my other Twitch channel, my gaming channel. And how's it going, Itu? How's it going, Zach? How's it going? Oh, a lot of you guys are here. When I get a check. Yeah, happy 50 followers. Right. Yeah, so I want to thank you guys so much. Thank you guys so much for actually getting us to this point. And you know, it's kind of funny because I wasn't like, I kind of expected the because since we did have over 50 followers, I was expecting the affiliate email soon, but at the same time, it's like, it's funny that it actually comes up when I decide to play a game on this stream. So it's just really cool that you guys are like gathering up and being here. So I thank you guys so much for actually getting us to the affiliate status. Now, of course, like, we're not going to be making bank or anything, but at the same time, it's like every little bit helps. And, you know, like, it's actually great to be able to, like, you know, make a tiny bit just to do math, you know. So thank you guys so much. Okay, I've done my thank yous, and you know, you guys deserve the most credit, so I give you guys the credit and everything like that. I was going to add something silly about frequency, but I got distracted. No, it's okay. So let's see who's here in the chat, just to make sure. Because I want to give a shout out to Zach, because he is also an awesome math streamer. I'm pretty sure, Zach, you're still doing your series streams, right? So if you guys are into like series, linear algebra, check out Zach's streams. Let me just, oops, I almost forgot to do the command. There we go. Yes, Infinite Series, though on a hiatus this week. No problem, yeah. Hey, Bamboo, how's it going? What's the best part? Actually, what's the best part of everyone's day so far? Put it in the chat. Because, you know, I'm energized, and hopefully you guys are energized as well. Thanks to Sasha, you know, I give you a pat on the shoulder for actually introducing me to this particular, I guess, game, I think. So apparently this is a game that teaches you how to do math proofs. I have not touched this game, I have not played it. So hello, Pobo, if you don't mind me calling you that, because you just have numbers afterwards. Are you on at the same time as let me see. Are you on at the same time? I'll see if I can get you added on the calendar. Yeah. Every time when I stream, Sensation Black, I usually stream at the same time, Monday through Wednesday. So yeah. Anyway, let's get this game started, because I don't know if I'm gonna put the study timer on, because this is technically a game, so I think it's something that we all can have fun with, because we have a lot of people that are really good at math or physics, but mainly I think this is mainly math focused. So let's get into it, shall we? Okay, so this is probably going to be a little bit of reading, so let me see here. Okay, I'll read it all out loud. So let's see. Welcome to the natural number game. I can't even read. And introducing to mathematical proofs. In this game, we will build a basic theory of natural numbers from scratch. Our first goal is to prove that 2 plus 2 equals 4. Next, we will prove that x plus y is equal to y plus x. And at the end, we will see if we can prove Fermat's last theorem. Ooh, okay, that's very ambitious. We'll do this by solving levels of computer puzzle games called Lean. Okay. Read this. Learning how to use an interactive theorem prover takes time. Tests show that the people who get the most out of this game are those who read the help text like this one. Okay. To start, click on tutorial world. Note, this is a new Lean 4 version of the game containing several worlds which were not present in the old Lean 3 version. Okay. More new worlds, such as strong induction world. Ooh. Whoever created this, they tried to be more creative with it. I like it. Even odd world, prime world are in development. If you want to see their state or even help out, check out the issues in the GitHub repo. Okay. More. Let's see. Click on the 3 lines on the top. Select the game info for the resource links and ways to interact with Lean community. Okay. Okay. So I guess this is what we're gonna go with. I'm excited to see Lean from the very start. Oh, okay. So I don't know if any of you guys have done this before. I'm actually trying to. It's no game. Let's see. Watch VODs, AI do AI. I'm excited to see Lean from the very start. So for the content of Lean is an interactive theorem prover. This game was made for introduction course to proofs for undergrads. Okay. Could you increase the text size slightly? I can try. I haven't done it on my browser, so I don't know if I have the tools I need to do that. Control, yeah, that's what I thought. Control plus, let's see. How's that? Is that better? I can try to do it again. That's better? Okay, cool. Okay, so this is the first time I'm doing this, so let's give it a whirl. Yeah, hopefully you guys are doing well today. So I don't see anything. What is it that I must do? Something's supposed to pop up? Oh, wait, do I have to click start here? I don't know if oh yeah, click start. Okay, cool. Okay. Alright. Okay, so... Wait, this is not the answer, right? I hope it's not the answer. Oh, achieve goal. Okay, so I guess it's like showing you what to do a little bit. Like a little bit of hints, I guess. Let's see, if x and q are arbitrary natural numbers, then 37x plus q is equal to 37x plus q. Okay, achieve active goal. Okay. And the goal is to get... Yeah. Okay. So execute, I'm guessing, is that what we write after we're finished. Okay, so I'm guessing we type this out. Let x and q. I mean, am I supposed to type this in like LaTeX or something? Because I don't know how to type that. I'll look in the instructions. Okay. Oh, the instructions on the side. Okay, I didn't see that. This is my first time playing, guys. Thank you for your guidance. Type RFL. Let's see. Each level in this game involves proving a math theorem. The goal. Okay. The goal will be a statement about numbers. Some numbers in this game have known values. Those numbers have names like 37. Other numbers will be secret. They're called things like x and q. We know x is a number. We don't know which one. Okay. In this first level, we're going to prove the theorem of 37 times x plus q is equal to 37x times q. Okay. You can see x and q are the natural numbers in the objects below, which means that x and q are numbers. Okay. We solve goals in Lean using tactics, and the first tactic we're going to learn is called RFL, which proves all the theorems in the form of x equals x. Okay, prove that this equation by executing RL tactic. In order to use tactic RFL, you can enter in the text box and then hit execute. Okay. Execute. Level complete. Okay. Now, congratulations, you verified the proof. Remember, that is a tactic. If you ever want information about a tactic, you can click on the list. Okay. Now, next we learn RW. Okay. 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 In this level, the goal is 2y equals 2 x plus 7 times x plus 7. Okay. But to help us, we have an assumption h. Okay, saying that y is equal to x plus 7. Check that you can see h in your list of assumptions. Okay. Lean thinks of h as being a secret proof of the assumption, rather like x is a secret number. Okay. Before you use RFL, I can't read today, we have to substitute in y. We do this in Lean by rewriting the proof h using the RW tactic. What you guys type? So RFL stands for reflection. Oh, okay. RFL is the x equal x reflexive reflection rule. Oh, okay. So it gives you a proof of equality if both sides are equal. Okay, so yeah, so it's like reflection. Okay. So first execute. Okay, so we have to type in RW. Oops, wrong parentheses. There we go. And H. First execute by replacing, right? Rewrite rule. Oh, okay. Rewrite rule allows us to rewrite the expression. I think H is just basically what is I guess the coded version of y equals x plus 7. So basically H in the coding stands for y equals x plus 7. Is that correct? I'm trying to answer Pablo's question. Comes from the hypothesis here. Oh, okay. So it stands for hypothesis. Okay. But I guess in coding, it's sort of like acts as sort of like the letter we need. Yeah, you're right. Okay, okay. Cool. Okay, so we'll first execute this. We'll execute. Can you take it from here? Click on show help. Okay, so we did that first, and I think we're supposed to do RFL for this. Because we just did that, and then level complete. Okay, so so I'm guessing I did all this, right? So like, because this is the original question, and then we were supposed to do all this, but we're just supposed to type it in ourselves, right? Because, I mean, I just typed this because they told me to, and I basically typed this because I felt like that was what they taught us before. So, like, I'm just trying to better understand the way this works, so that way I can have a better idea of how the rules of this game works. Let's see, I want to see what like, how does HW work again? RHW work again. Oh, they show you what you typed and then basically what's going on. So let me just read what you guys typed, so that way, yeah, so we basically just substitute y by, so does just multiply both sides by 2, or it can't be right. Okay. So my guess is that, like, when you do the rewrite function, I'll just call it a function. I don't know if I should call it code or function. Replace with A and B, yeah. Because I think the rewrite function is supposed to reiterate what is it that the assumption is. I think. Right, so it just rewrites y as like x plus 7. Okay, so basically it reiterates what we are assuming in this case. Okay, so let's try next and let's see what we got. Okay, so what do we got in the instructions? Okay. Oh, this one's a longer one. Okay, numbers in Lean are defined by 2 rules. 0 is a number, and if n is a number, then the successor of n is a number. Okay, so the successor of n means the number after n. Let's learn to count and name a few numbers. Okay, so count to 4. 0 is a number to, so yeah, 0 is a number, so 0 is a number. Let's call this new number 1. Similarly defined, 2 is equal to, okay. This gives us plenty of numbers to get along with. Okay. The proof that 2 is the successor to 1 is called, oh, okay. Check out 0, 1, 2 tab in the list of lemmas on the right. Do we have that? Oh, right here. Yeah, I see that. Yeah, I see that right there. Let's see. Let's prove that 2 is a number after the number after 0. Oh, okay. So start by the rewrite command with 2. Oh, this is pretty fun actually. It makes me feel like I'm coding. I don't even know if this is a coding language, to be honest. To begin to break 2 down into its definition. Okay. So let me just check. I just want to make sure that I know what I'm doing here. So 2 equates 1. The proof that 1 is equal to the successor of 1. Okay. So we're supposed to execute this. So execute. Oh, okay. So each time you type a code, it shows you what goals you've achieved here. Okay. You can take it from here. Oh, okay. So the success of 1 is equal to the success of 0. I think we're gonna have to rewrite again. So, oh, whoops! I didn't click on the thing. So if we had 2 before, so 1. I'm just trying to use my brain, so that way I'm just learning as I go. And plus, it feels, and plus, like, I guess, quote unquote, it feels like a game. So now it just basically, it kind of like, how should I say? It kind of feels as if I'm just like trying to learn the tutorial, like for like, which buttons to press. Let's see if this works. And where do we go from here? Do we have to reiterate? Equals 0. So, I mean, we did prove what we proved, right? So, no, wait, hold on. The success of 0 is the success of 0. Is that right? Let's see the number. So, success of 0 is a number. So let's call this new number 1. Maybe I didn't type that right. Because the success of 1 is equal to the successor of 0. No, I think I did it right because it equals, they both equal each other. But then it basically says the successor of the successor of 0 is equal to the successor of 0. I mean, we could get wrong answers here. If I'm wrong, then I will have to face the consequences. Level complete. Okay, so let's see. Note you can do... Oh, okay. And then solve this in 2 lines. Oh, okay, okay. Let's see, I posted the link if you want to play along. Oh, thank you for posting that. Yeah, I'll allow it. I'll allow the link there. I didn't notice that, Sasha, but thank you for posting that. And I also thank you guys and appreciate you guys for not, I guess, quote unquote, trolling with the links, because I haven't turned it off because of like, you know, the link blocker, because you know, like, you guys have posted links to help me, but you know, just a forewarning, if anyone abuses it, I will have to turn it off. I mean, I have to turn it on, that's what I mean. So nice. So the goal thing is to change the until, and now maybe I prefer to leech off of Mathspellbook's brain. I mean, you guys know a lot more than me, so I'm pretty sure you guys are like, basically like, oh, this is easy. I know how to do this. Okay, rewriting backwards, okay. So if H is a proof of X equals Y, then RWH will turn X into Y's. But what if we want to turn Y's into X? To tell the rewrite tactic we want this, we use the left arrow. type /1 and then hit the space bar to get this arrow. I don't know if that's a backslash. If it is a backslash, let me know, because I don't want to be reading the wrong like symbol. So if two things are equal, you can change one thing to the other in either direction. Yeah, I think that's how it is. I think it's a left arrow. Yeah. Okay, so let's prove that 2 is a number after the number 0, after the number after 0 again. This time by changing into 2. Okay, so try. So we have to type this, and then no, I don't think that's right. Oh, that's a straight one. Then hit this. What am I doing wrong here? Is it supposed to be like that? Then no. Why is it giving me a small 1? Oh, okay, so I have to do it this way. Okay. Thank you, Jeff. It's probably that, yeah. So 1. To change into 1, okay. Alright, so I think we typed it out. No spelling mistakes? No, I don't think so. Type /1 and then hit the space bar to get the arrow. Huh? Then hit the space bar. Oh, maybe I wasn't doing that. So no? Why is it a tiny 1? Not 100% sure. That's hey Mavort, how's it going? What's the best part of your day so far? I swear this music sounds like Paradox interactive music. Oh, it's not a 1, it's a lower. Oh, it's a lowercase l. Okay. That's why I was confused. There we go. Yeah, like from what I saw, it looked like a 1. I was like, is that right? Okay, thank you, Sasha. Okay. Can you imagine now to change the goal into 2 equals 2? Okay, so let's see. We have rewrite 1. So we change that to 1. Oh, the successor of 1. So that means we have to change that to 2. So the way we had this set up, so basically the rewrite function, this one, so basically we had 1 equate to 2. I mean, equate to 0. So I think we have to do the rewrite function, and let's see, we wrote 1 there, but it says the successor of 1, so because it basically turns one, basically changes 0 to 1. So, try to change this. Okay, so the left arrow, basically switch it around, so now I have to actually think about how the code is gonna like react to each other. Hey Storm, how's it? Hey Storm Dupane, how's it going? What's the best part of your day so far, my friend? We're trying out this new game. Well, I don't know if it's a game, but it feels like it's sort of a tutorial type of like proof, like I guess interactive proof like creator. So Sasha basically introduced this to me like last night, so I was like, oh, maybe I should try it on stream for you guys. So you can see the theorem. You can use the right side. I'm gonna try stuff out. See what it looks like. It might not be right. It's probably not gonna be right, but I'm gonna like see what happens. Because I want to rewrite this. Oh wait, maybe I should do it like this, and then wait, where's my mouse? Oh, here it is. So maybe I gotta do this. Let's see if this works. Oh wait, hold on. Do I have to do something else first? So let's try this. Then change it into 1. So we did that. Okay, so we just have to change from 2. Alright, so let's see if this works. No. I have to do it the other way. So I probably have to rewrite this. Maybe I have to rewrite this. So let's see. Do this. Then /L space. Let's see if I can get it back to the way it was. Let's see what happens. There we go. Okay, so without the arrow, it basically just changes the left-hand side of the equal sign. Okay, so when you put the arrow, it changes. Okay. That makes more sense. Well, it could work. Our goal is now success. Yeah, right. Yeah, I think that's how it is with, like, I guess, like, doing a little coding with it. But I don't think I succeeded in this one because I don't see a next. I don't think it's gonna let me click next. Is it? Can I click next or? No, I can't click it. Okay, so that means I have to get rid of one thing. So I would have to redo this one. Retry this one. So I have to type in /L. Then okay. Oh yeah, that's right. We have to type in FL. There we go. Okay, so okay. Thank you for reminding me, Jeff Groves. Oh, okay. It's a QED. Okay. Thank you. Let's see. Why not define? Why did we not define just n to be 1 plus n? Okay, because we have not even defined addition yet. We'll do that in the next level. Ooh. Okay, I like this. Whoever created this, I like it. Because it lets you build math in a more naturalistic way with proofs. I actually like this. This is actually really good. And plus it kind of makes you feel like you're getting into coding too. I mean, I don't know if this is a coding language, to be honest with you. Like, is it a coding language for specific, like, a specific software? Like, Sasha, like, is this like a specific coding language, or is it just like language for just this thing? Yeah, it's a programming language. Oh, really? Does it have a specific name, or is it just called Lean? Yeah, because, like, yeah, Jeff Groves, Sasha is like, the Keller cone. Yeah. It's just called Lean? Okay. This looks more like a theorem prover, such as, oh, I've never heard of that. Maybe I should do that one next stream, before. If you have a link to it, provide it in the stream resources page. Maybe I'll probably try that next stream. And hopefully you guys are not bothered by my model just zooming in and out, because, I'm doing this on my tablet and I'm kind of looking down and up, but, because I don't want to put it on my main monitor. Doing math with axioms is really the less entertaining way to do it, in my opinion. For me, we must do it one time to ensure that all define a solid basis but never touch it again. I've never used theorem prover so far, so I don't know about it. Oh, okay. Alright, so let's see. Okay. We'd like to prove that 2 plus 4 equals 2 plus 2 equals 4. Okay, but right now we can't even state it because we have yet to define addition. Okay, so defining addition. How are we going to add 37 to any arbitrary number x? Well, there are only two ways to make numbers in this game. 0 and successors. So define 37 plus x. We need to know what 37 plus 0 is, and what 37 plus the successor of x is. Let's begin by adding 0. Okay, to make addition agree with our intuition, we should define that 37 plus 0 to be 37. More generally, we should define a plus 0 to be a for any number. So the name of this proof is in Lean. So is add 0, and for example, oh, okay. Add 0 to x. Oh, that's convenient. Is a proof of, okay. We write at the 0. So proof equals statement. Okay. So rewrite. Oops, no, wrong button. Add 0 will change b plus 0 into b. Execute. Okay, now Oh, let's see what they have here. I didn't even look at the main prompt here. So it says a plus parentheses b plus 0 plus c plus 0 equals a plus b. Oh, okay. So that's basically what we're supposed to prove the addition of 0 with any number. Interesting. Okay, so like I know I'm probably saying the obvious things, but it's just me restating stuff so it records in my head. So that way I'm basically thinking my thought process. I don't know if like people, I don't know if you guys like state your thoughts loud in your head when you're doing a problem. For me, I think it just helps me like summarize things a lot better. Because I know I'm being super Mr. Obvious here. Basically just like, it's like, yeah, that's obvious. That's obvious to us. Why are you repeating it? To change. Okay, so basically it just changes those. Okay. Alright. Okay. So yeah, so then we proved that, so we can just type. Okay. We didn't have to do any extra steps. For those of you interested in speedrunning the game, may want to know that repeat will do both rewrites at once. Okay. That's good to know. So we just have to remember repeat. That's not too hard to remember. Precision rewrite. In the last level there was changed from the first okay. So rewrite add 0 C. Let's see what we got. Oh, okay, so you can clarify which variable it is. So as proof is rewritten, you can now change B by rewriting B. Okay. You can usually stick with at 0 unless you need real precision. Okay. So let's just do that. 0. Oops. Wrong line. It's supposed to be underscore. There. Boom. And then. Okay. Let's now learn about Pino's second axiom for addition. Addition with success. Okay. Okay, so I'm guessing like the add underscore, like after the underscore, basically tells you like to rewrite the, I guess the thing in parentheses. Oh, you guys typed a lot. Let me just check out what you guys typed. Oh wow, I missed out a lot. Let's see. Okay, this is where I left off. Lean is more mathematician. Is in my opinion is for computer scientists and electricians. Oh, I prefer the purity of the foundational mathematics. That's fair. So a theorem prover is just programming language with thank you for the follow actual education. Oh wait, I probably should give you a shout out actual education, because I know you stream like physics and math content. And if you're in the chat, like, what's the best part of your day so far? I'll give you a shout out, because I have seen your streams before and they're very, very helpful to people. Yeah, if you guys have not heard of actual education, check their content out. They help out basically like people that are struggling with physics problems, math problems, you name it. It's like the tutor that basically always constantly helps you at a certain time for office hours. Let's see, now I gotta remember where I left off. Let's see. Just choose the left-hand terms here. Because the branch math you study nothing, you ask yourself if math is doing to make sense. What are the limits of it? You can just... Let's see, the only thing I state with my voice is when you're Anubis, I'm a dummy. Usually it's... Oh, Tyrion, you're always so funny. Actually, Tyrion, how's things with the path was it the Feynman path integrals book? I actually got to start like doing that. Because I know last time we talked, you were like on chapter 4 of it. Oh no, you were on chapter 5, I think. Let's see. I'm not sure to understand what on mean by foundation. But here I talk about logic, the study of axioms. I mean, like with physics and mathematics, like I feel like the physics allows me to visualize the math a lot better, whilst the math kind of gives me a sense of, ooh, there's something physical I can imagine with it. So it kind of helps me go hand in hand with it. So, but I get what you're saying, Storm. Let's see, are you introduced to set theory axioms cause useful outside of algebra and number theory? I'm mostly interested in calculus and differential equations. Yeah, I'm the same way, Mavort. I'm interested in like the hardcore stuff. I'm actually watching videos on partial differential equations. Like, not to like do problems with them, but I'm actually like learning more and more about the heat equation, which is really interesting. But abstract algebra is interesting. Yeah, I want to also learn abstract algebra because it does seem like it's fun. All of math is ultimately the rewrite rule, right? You can do so. Yeah, I'm like so behind. Let's see. I'm going into chapter 5 after I make notes on chapter 4. I wanted to do some repeat some of my calculations on my own. Oh, okay. That is fair. That is fair. Okay, so I'm caught up with chat. And also, thank you again for the follow, Actual Education. Much appreciated. Actually, having you guys in chat today, like, makes me very happy. Because, like, not only did we hit affiliate, we also are basically just, like, you know, it feels like I'm actually doing the right thing. Like, basically just, like, streaming my math journey with you guys. Even though I am not, like, a student or anything, I feel as if, like, this is sort of, like, I'm kind of, like, in a class with, like, a lot of, well, not in the class, but more like in an office with, like, a lot of people that know their stuff, and it just feels, like, inspiring to me. So, chat is very inspiring to me. You guys are an inspiration to me, because I know you guys know a lot more stuff involving math, and also physics. So, yeah. Okay, every number in Lean is either 0 or a successor, okay? We know how to add 0, but we need to figure out how to add successors. Let's say we already know that 37 plus D is equal to Q. What should the answer to 37 plus the successor of D be? Well, successor D is bigger than D, so 37 plus the successor of D should be the successor of Q. Makes sense. The number 1 is bigger than Q. More generally, X plus the successor of D should be the successor of X plus D. Sorry. Let's add this as lemma. So I'm guessing I have to type this out. Or are we just leaving that there? If you ever see ... plus success ... your in your goal rewrite as is normally a good idea. Okay. let's prove that the successor of n is equal to 1 plus n. Figure out how to get plus success into the picture, and then rewrite. Oh, okay. So now we have to assemble our own code. Okay, so this should be interesting. Okay. Okay, so we already have the success end part, so we don't have to worry about that. So if we don't put an arrow, then that means so we rewrite dot, and then we do \L space, and then we have to make sure that n. So figure out how to get the into the picture, and then add success. So is normally a good idea. Okay, so let's look at the code again. So now proof that it's gonna figure out. I felt like I had it in my head and then suddenly I just lost it. Because we already have this part, and what we have to do is change this right side here. So figure out how to get plus success into the picture, then rewrite add success. Okay, so we have this. So the successor n, so basically we want n successor plus 1, or we want them to equal each other. How to get plus. Because we can't have this to be just the successor of n. This has to be why am I blanking out? I feel like I'm seeing I know the pattern. It's just that like my brain is like not contemplating what I should type here. Like I'm feeling like, what's wrong with me? So they have 37 plus, so we have the successor of n, and then it's like n plus 1. Oh, let me see here. Okay, this is where I stopped the chat. Let's see. The study of partial differential equations is not really what you can think of when you have done some differential equations during high school. Studying partial differential equations is full of measure theory and awful set. But there is really beautiful results sometimes. For example, the Lexman theorem is really cool. Ooh. Actually, I'm just gonna, let me see if I can copy that. Luckily I have a notepad open. Let me just put that there because I'm not gonna remember that name. So I'll just probably define that as math notes. So theorem. So like if you need to check the definition or the theorems, you can always check on the right. That's your inventory. Oh, okay. I think you need to apply the success equation to add 1, but to n instead of a. Alright, so definitions. Oh, here we go. We have definitions here. Okay, so we have to define this. Have you ever seen it? Figure out how to get plus success. successor of n is basically like 1 plus n, so... oh yeah, here we go. I didn't read the theorem. I probably should have read the theorem first. Let's see, successor n. For all natural numbers a, we have the successor of a equals plus a plus 1. Okay. So we have to solve this theorem. Like I keep forgetting I have to do that. So all right, so we have to rewrite this side. We'll go with what you suggested, Jeff Groves. So apply. But instead of n, but to n instead of a. I realize that might be a mistake. We're trying to prove my mistake. Instead, look under the tab, under the plus tab on the right. What is this? Oh, here we go. Like it adds success. Let's see, add success. X and D. Which is equal to, so you would have to type add and oops, 1, or maybe you have to type 1. So type 1, then success. Right, is it? No, I'm probably rethinking something. No, I don't think that's it. Doesn't feel right. I was about to ask you to do that. I want to see what the rules say. Dang, my mouse is like. Oh, whoops. Let's see. Oh, I guess I can't. I guess I have to type it out by hand. So. Type out the numbers. N plus success 1 equals. Let's just have fun. Let's just do it anyway, even though it might not be the right thing for us to do. Oh. Okay. Let's see what happens. Nope, that's not right. Okay. So maybe we just have to put the command in. Let's see if that works. No. Okay, so now we're actually up to our wall here. We're actually gonna have to actually think deeper about this one. Click the yellow text on the right. Let's see. Add, so add this proof is Is this all like just one command, or is this have to be in the rewrite part? I think it has to be the rewrite part, I think. So, what is my nat? Like my nat plus success D. What is that? You just need to use it. They already added that lambda for you. Oh, maybe my natural numbers. That could be it. So oh, whoops! I almost forgot that part. Oh, whoops! I want a dot. Don't worry about the part is the type, but don't worry too much for now. I think you need with A as N and D as 0. Okay, might as well go with your suggestion, Jeff. Why not? So 0. Alright, I'll give you a hint. In order to use we must have something of the form A plus A. The rule name is just the rule name. Oh, okay, so take this out and then just type in this. Oops. No. So 1 is the successor, 0, right? Right. Okay, okay, so alright, let's see. And all the natural numbers A, we have the successor of A is equal to A plus 1, so meaning because let's see, n successor n, because we're supposed to make a proof out of this, and the goal is to basically show that n plus 1
let's see. So in order to apply, let's see. So in order to apply rewrite at, and then we need to have something in the form of or. In our goal, is that the case? Because let's see, for all natural numbers, such as we have the zone. So wait. So in the theorem we have this, the successor equation at +1. Because we have to establish this first, right? Because that's what this is, right? Yeah, because it's basically the successor of A +1. So I'm trying to formulate in my head now. I think you want to rewrite okay, so and I mean our current goal is, do we have something of the form A plus successor B, or so do we have to pick a different number besides like n+1? Like, are we trying to do like the successor of x plus, like say A plus B, and then basically just put like B plus the successor of I mean A is plus the successor of B? Or is it that we're just trying to like prove like, you know, the successor of n is, or the successor of A is equal to A +1? Because now I'm actually getting confused of what the priorities are for this particular theorem that we're trying to do. Because I know the goal is this, but I know that it's supposed to reflect off of this. Alright, let's try what just did. Oops. It's the first roll. So now we want to prove this. That's the current goal. Okay. So what happens if we type this in? One queen. AFK 1 minute, no problem. I think it's supposed to be on the left side, right? No, that's not right. Okay. Maybe I have to reread what I've read. Let's see. Every number in lean is either 0. Okay, so the goal is to prove that the successor of n is equal to n+1. Okay. So does that mean we have to make it so like what am I thinking? Because I was thinking that we have to do like the successor of n+1 or n plus something, whether it be x or a or whatever, a random variable,
and then you have to prove that that is it. But I don't think that's the right approach. Hey, welcome back. Oh, maybe that's it. Yeah, maybe that is what we need to do. This work? No. End of input. So use rule 1. Oops. Didn't mean to do that. Rewrite 1. Right, let's see. Okay. Oh, okay. Now you use, oh, okay. Rewrite, beat you to it, oops. Yeah, that's what I was thinking. I was like, that doesn't look right. Oh, okay. Interesting. That is pretty interesting, actually. It kind of is like the, what is it? Like the distributive property in some ways. I don't know if that's the right terminology, but it kind of reminds me of that. There is a add 0 rule in your inventory. Yeah, I think I made that too complicated. I think I made that more complicated than it already had to be. Or maybe I just didn't get the goal. I didn't get the priorities of like the goal, because I think it was swirling in my head. That's why I was so confused. All right, so let's just recap on what we learned, so that way I don't get confused the next time. So yeah, our priority, I knew our priority was this side. I think the reason why I was so confused is because like I was like, okay, I know this is a fact. I just didn't know exactly what the goal, like I guess the end priority was. Like to like basically like, yeah, I looked at it and I was like, yeah, duh, but like so what? And then I was like, what more do we need to do here? And then like when I started like actually like seeing what you guys typed up, and then I was putting it into the machine, I don't want to say it's machine, but when I put it in the actual I'll say game, in the game itself, like, or the programming, I guess like the blackboard or whatever it is, I was like, oh, okay, so we just had to simplify it more and more, and I guess I didn't see the simplification. Okay, so this will turn this, and then this will basically just make it more like on the successor part. Yeah, so basically we just want to have something in the form of, I think that's how mathematical proofs are, I guess. It's like basically like, how should I say? It's like, oh, I almost forgot. Don't want to forget this part. Oh, whoops. Oops. I forgot the last part. Let's see. Successor and... Okay, so what else do we need to do? Start by unraveling the 1. Let's see, fail to... it's not dimensionally equal to... Successor of n, so... you need to add the 0 rule. Oh, okay. Let's see, let me see. Add 0. So I'm guessing we have to rewrite. So rewrite. Oops. I'm pressing space when I shouldn't be. Okay. Add 0. Right? Yeah. Okay. And right? Here we go. Okay. Alright, so we got the oh, you want to make them equivalent to each other, okay. Because the successor 0 is like considered 1. And then basically, and is it then, oh, okay. Because basically, since it's 0, basically we can just consider it like that. Okay. In order to use both sides exactly the same. Oh, okay. Okay, that makes more sense. So add 0. Like now, like because we struggled so much and it took us so long, I was like, oh my god, I think I hopefully I don't forget everything that we've learned. Okay, good luck. One last hint. If h is equal to x equals y, then rewrite h. We'll change all x's into y's. If you only want to change one of them, say the third one, the third one, then use nth rewrite 3h. Okay. Alright, so I guess we're gonna have to do a rewrite, so rewrite. And so the last one, we learned more about the successor rule, the success rule. So we have like, excuse me, sorry about that, guys. Let's see, 2. success 1. So our goal is to make it 2 plus 2 equals 1. So that means if we look at 2 as the successor of 1, then the successor of 1 plus the successor of 1, then that would turn into successor of 1 plus 1, which is 2. But then, no, I don't think that makes sense. I start with 4 is equals to the successor of 3. Okay, we could try that. Yeah, we could try that. That sounds like a pretty good idea. So we can try that. Okay. And then I think we have to change one of them. We have to change one of them to be the successor of 1. And then we would have to rewrite it as like the successor of 1 plus 2 plus 1, basically. And now maybe 3. At least that's all 2s now. Okay. So the successor of 3, and then 3 is equal to the successor of 2. Okay, so whenever you type this specific code, it basically makes like whatever you put in it like basically like a successor or something. And when you put it in a successor within a successor, it basically puts it in together. Okay. Now we're gonna have to change up the other side. I mean, we did learn something from that, so maybe get rid of that, yeah. So I think we can change the left side instead, yeah. So the successor of 3. So I'm guessing we're gonna have to change one of these two into like the successor of 1, and then we're gonna have to do the other thing, which is the add success function. Apply equation 2, but are you saying nice to the idea I suggested, or something else? In general, I would advise to start with the more complicated side, but you probably do it like that anyway. My idea? Okay. Okay, so now I have to figure out how we're gonna do this. So actually, Sasha, do we have to always type out the numbers instead of just like, I mean, type it out in words instead of like the actual numerals, like the Arabic numbers? Because I always notice that whenever I type it like the Arabic, like the way it looks normally, it's red. So we actually have to type out the numbers, right? The idea I was typing out. So
got A and B, so let me see here. No, wait. What am I doing? What am I doing? I have to do this first. Yeah, there we go. Yeah, because we have to turn one of them. So basically, last hint, if if h and y equals y, rewrite and to change all of this. If you want to change one of them, say the third one, then nth rewrite 3. Okay, now I'm like, I know it's basically saying that we can change one of these. The one thing I'm confused about is that because it's like basically like this, like I'm like, where's the third one? Like, what is it talking about? But then again, I don't know if this is just providing just an example of this particular thing, and then basically just stating out this, but then like basically it's assuming that you're just making up like an equation that basically has 3 parts to it. That's not related to this. Oh, sorry. Where can I put the chat where it doesn't? Maybe I have to put the chat in the bottom. Let me just... Maybe I have to put it down here. There we go. Sorry about that, guys. I forgot that you guys can't read on this side. It provides an example of using nth rewrite. Let's take a look. Oh, my mouse is on the other monitor. I was like, why am I fidgeting here? This is rewrite. What is this? Oh, that's nothing. Okay. Success. No. That's success. Okay, so we can just click on these two. So I think you want to write nth rewrite 2. So let's just try what you suggested, Sascha. So nth rewrite. So rewrite 2. Oh, whoops. We have to type out the numbers. Then put another one where it's like 2 equate to success of 1. Not inside of rewrite. So just take this out. So basically I'm thinking like what you mean is this. Yeah, but 2 in the number. Oops. But why is the 2 red? Like, why is it red, Sascha? Like, is it just red for like specific reason, or is it like wrong, or is it like just red because it's programmed to be red? Because we're using programming in a sense. Oh, okay. Alright, let's see what it comes up with. Unexpected n input. Oh, that's just code highlight. Oh, okay. You need to use the rule. You want to use the rule. Which is oh, okay. So I'm guessing I have to do this and like that's what you mean, right? Like basically just have the basically because this is considered an R a rewrite, but it's like sort of replacing RW, right? So 2 here is mean the second and oh, okay. So this is considered like another version of this. Okay. That makes sense. Okay, let's see if this works. Okay. So then we gotta add the success command. Right? So then we have to rewrite, right? So rewrite dot oops, wrong one. Space. And then 2 plus success 1 is equal to success 2 plus 1. Let me see here. Wait, forward direction, not reverse. The rule. Add success. So I guess we'll take this out. And then okay, so let's do that. See? Okay, and then we have to rewrite the inside. Let me see. At 0. Now I have to remember what is it that I have to do for adding just these two together. So that function is for this. Add 0 is just add 0, and this one I think you need to add 1. Okay, so yeah, I think so too, because that's the only one that makes sense for us in this particular scenario. Okay, so let's do this. Nope. I think I have to type something else. So we'll retry this. Okay, so it's not this. You want to go, but reversed. You want to go from n+1 to success n. So
hold on. So wait, when you say reverse, do you mean this command? The L backslash? Is that what you mean when reverse? Oh, okay. And then we put the same rule we had before, right? So like that, right? Is that what you mean, Jeff? Okay, let's give it a try. All right. And then we have to change that. So we have to change the success to a number. So don't add a success. Let's see, if we do add 0, I'm just looking at the setup, I'm not actually going to do the operation. Let's see, it does add 0, then add success, so is proof that is A. So if we want that to be rewrite, at least I know how to do the rewrite thing. Then this point, because so the backslash L makes it reverse back into its, so that means we want it to reverse back into numerals. Oops. Right? Then now we have to change this into remember you have different tabs for rules. Just want successive. You just want this. So replace, but backwards. But backwards. Actually, forward would work too. Oh, okay. So 3 is equal to. Oops. Changes 3 to choose. So wait, so shouldn't it be like this then? Okay, yeah, your comment was confusing me. That's why I was like, wait, what? Remember to reverse the rule. Okay. Typing 1 when it should be just the L. Remember to reverse rule. You use the R. You use the arrow. Alright, how's this? I just want to make sure because I know you guys are probably watching from other parts of the world, and like there's probably like a lag, not a lag, but like a like a difference in timing. So let's do that. Okay, and then we get, oops, R, L. Okay. Level complete. I mean, I felt like you guys did a majority of the work because I was just basically just thinking about it, but then I couldn't help but look at your comments in the chat, and I felt like a majority of you guys were doing the work than me. And I was like, do I really know this, or am I just relying on you guys? Yeah, no, you're doing fine. Okay, this time we will let you do it on your own. Okay, let's see. No, you're doing fine. Okay, thank you, Sasha. I appreciate the supportive words. But this is fun. I actually think this is really fun. Maybe I should do like these on my own, like on like the times when I'm not streaming, because I think like this also helps out with thinking about mathematical proofs in a different way. I think this is really interesting, because now I can actually see like what I type up in the proof techniques. For a first time, you're doing very well. Thank you. I appreciate that. Actually, I think math proofs would be a lot more fun if it was done this way, because it seems as if like you're basically having your thought process and you're just trying to put the right code in, which I think is sort of like the same like how proofs are. It would be cool if at some point you could do some more interesting advanced math with Lean on stream. I mean, if this game gets more advanced, but it starts me off on a basic level, I mean, I'm not taking that out of possibility, especially if the developers are still developing the game. You know? I agree. I think all proofs should eventually be required to do this. Yeah. Actually, I think this is good enough for like even high school students to do, because it feels like the way they introduce it, it feels as if it's sort of like introducing you to like how mathematicians think. At the same time, it feels like you're doing it through the eyes of a programmer, which makes it a lot much more interactive, I think. This isn't just a game, it's an entire language. Yeah, I know, but at the same time, it feels like a game to me. And I think that's usually how, when you think of puzzles, it's sort of like that. It's like sort of like a game in a way, because it feels like it's its own little construct. A lot of people have proved very modern theorems in Lean recently. Oh, nice. Oh, hey, actual education. I didn't know if you were in the chat. All kids try to use ChatGPT to find a shortcut to the game. But what's the best part of your day so far? Actual education. And thank you for the follow from before. I don't know if you heard me then. But yeah, like, actually, I love your streams, actual education. It seems so pro, because it's like you're helping people with their physics and math problems, and it's like, wow, like that's like, but you make it sort of like have this vibe of a radio show, which it makes it like more, it makes it like more towards like entertainment, or edutainment, I should say. Like it's educational, but also and entertaining. Even Terrence Tao have to rewrote a paper of his Lean. Oh, we got somebody who's an interloper. We don't need that person there. All good. Was teaching vector calc. Appreciate the compliments. No problem, no problem. I mean, like, the thing of it is that, like, when I see all the stuff that you're doing with the people that you're helping, it's like, wow. It's like office hours, but it's just more relaxed. Like, you know. Because, I mean, because I want to also get good at physics, too. The thing of it is that, like, obviously I haven't done like a full textbook on physics, like university-based physics. I did take an online course on it though. Like, I did take an online course in physics, but like it's been a long time since I've actually done physics problems though. I mean, I do know the kinematic equations. I know the equations for kinetic and potential energy, or at least like, you know, like mgh for potential energy. But at the same time, like, I hardly know I hardly remember anything about electricity and magnetism. So the addition world. I'm teaching intro physics in a couple weeks at UCLA. Oh, okay. So I'm guessing you're in California. Maybe I'll stream the lectures. That would be exciting, yeah. Because I think with, like, because I have physics textbooks. I do have, like, you know, University Physics by Friedman and Young. I think that's the author's names. But whenever I open a textbook, I see, like, the amount of problems that there are. And I'm like, oh my gosh, like, will I ever understand, like, the true essence of what physics is? Like, you know, because I look at the problems and I'm like, oh my goodness, like, do I have to know how to solve all these? I'm like, yo. There's much all at once, yeah. It becomes analyst paralysis, yeah. Because, like, I also want to, like, learn how to do, what is it? I had the, it's the problems that you do guesstimates. I forgot the name, what they call those. Not Freeman problems. It's like you basically do estimates in your head and they could be off, but Fermi problems, yeah, that's what those ones, like, when I look at a textbook, I'm like, what? Like, you know, like when I look at the answers in the back after I do the problem, I'm like, wow, I'm off by like 10. And, like, I don't even, because, like, since it's in a textbook and it's an answer, I keep thinking that, am I correct by getting it off by 10? Because that's what it says in the textbook. And then I remember I talked to you on your stream and you basically said it's okay if it's, like, over by 10. And I'm like, okay. It's just basically there to provide, like, I guess, reference. Anything over 10 to the 30 is you done goof. Oh, okay. That makes sense, yeah. So we have like 10 more minutes, so I'll probably do the first part of this part. I mean, I feel like because we have this, we have lean, I feel like maybe I'm gonna start streaming this stuff because it seems like it's a new, I mean, it's not a new thing, like probably to you guys that are in the chat, but it feels so new to me, and like, I feel as if it's kind of like more fun than just me just scribbling everywhere. But at the same time, it also helps me jumpstart on like proof writing, or at least like get an idea of how to construct proofs, if that makes sense. So let's see. Welcome to the world of addition. In this world, we will learn induction tactics. This will enable us to defeat the boss level of this world, namely x plus y equals y plus x. There's also a lean game for real analysis that I played a while ago. I can probably find you a link if you guys are interested. Oh, please. Yeah, absolutely. I would like to try that. But I would recommend the number theory game for now. Yeah, I will take your recommendation on that as well. Because I haven't done the proofs with linear algebra. And I know, like, I remember, Sasha, you told me that it's better to do proofs in linear algebra first before you do proofs in real analysis. I mean, that was your recommendation. And also my ability to do calculation-based math is also a bit, needs work. Because I remember yesterday I was trying to do a trig substitution problem, but then you guys in chat, you basically told me it was easier just to divide the polynomials together. And I actually had to, like, think about, like, exactly what you guys were explaining to me in chat. Let's see, the tactic, rewrite, and induction are only tactics you will need to beat all the levels in the addition world. Multiplication world and power world. Power world contains the final boss of the game. There are plenty of more tactics in this game. Yeah, because they even define it as a game, which I think is a lot, it makes it more fun and less academically pressuring. So that's why I think this is, like, pretty fun. Yeah. But you'll only need to know them if you want to explore the game further. For example, if you decide to 100% the game. Okay. And I'm guessing we still have the stuff that we had before, right? Yeah, so I think this is also good because it shows the codes that you've learned. and it allows you to think creatively on how to implement those codes, which I think is really, really cool. And also, if you guys are just tuning in, you're lurking, be sure to drop me a follow, please, because the thing of it is that, like, if you like math, if you like physics, or you just want, you know, like a good study stream to keep you productive on whatever it is you're doing, whether it be drawing on your computer or whatnot, any, like, follow helps, especially if it helps you, because the point of my streams, at least, like, the streams that I provide on this channel, is just to help you feel productive and feel like you're actually doing something that you really care about. Let's see, the base case will require us to prove that 0 plus 0 is 0, and the induction step will ask us to show that if 0 plus d is d, then 0 plus the successor of d is equal to the successor of d. Because 0 and the successor and its successor are the only way to make numbers, this will cover all the bases. See if you can do your first induction proof in Lean. By the way, if you are still in editor mode, actually, because I should have kept the chat, like, I should have kept the chat here, because we don't really need, like, the middle here. But the thing of it is that I think chat should be right here. That way we don't, like, because we just have the tactics on this side. So that way you guys can see it, yeah. Yeah, I just moved it. So I think we'll just do this, and then I think we'll call it an end for stream. Alright, so where were we? Oh yeah, the difficulty in proving that, oh no, I think this is, let's see. In this level, we're gonna prove that 0 plus n is equal to n. Where n is a secret natural number. We already know that, no. Add 0, this is 0 add, which is different. Okay. So now we have 0 and add and 0 add. I wonder where that's gonna be in. Or maybe it's added when we basically type it in. The difficulty in proving that 0 plus 0 in general only uses add 0 and add success. Once we know whether n is 0 or successor, the induction tactics split into these two cases. The base case will require us to prove that 0 plus 0 equals 0. Okay, we just read that. See if you can do the first induction proof in Lean. By the way, if you're using, oh right, we read that. So start. Okay, on n, type induction n with d hd. I wonder what the HD is for at the end. Now you have two goals. Once you prove the first, you will jump to the second one. This first goal is the base case, n equals 0. Recall that you can rewrite the proof of any lemma, which is visible in your inventory, or any assumptions. Display above the goal as long as it is of the form x equals y. Okay. So, let's see, the goal is to prove that n plus 0 is equal to n. So then we have to prove that n is 0 in this case. HD is your inductive hypothesis. Okay, we're not helping this time, right? Yeah. Like if you wanna offer like a hint or like help, like I always put it in like it's like on the automatic message. Basically, it's like type you need help or it's like you need a hint.
You know, just type like that sentence if I find myself struggling. So I'm just gonna think about this for a minute. Okay, so we have to prove that n is equal to 0. So we have to rewrite something. So we have to rewrite. Start with that first. And then wait, there's something else here. By the way, you're still using this to typewriter mode by clicking the arrow at the bottom of the right screen. Okay. All right, now. So I think what we need to do is let's see what happens if we do this. Okay, that doesn't do anything. Okay. Because I know it's not a successor of anything. So we'll just take this out. Because it says add 1. Unless it wants me to type underscore add 0 n. Let's see if that works. No. Unless I have to do it. No. Come on. Don't highlight it. Let's see. Nope. No, it's okay. It's okay, Jeff. I just put that there because I know like you guys are doing their best to help, and I know you guys are like watching it from different time zones. It's just that sometimes like I said before, there are times when like you guys like basically put out like what I should do because you're thinking about the problem at the same time that I am. Because like it's kind of like we're like collabing scientists or collabing mathematicians, and we're like, oh no, do it this way or do it that way. But at the same time, like for me, it's like I put that rule there because you guys are just like so smart that like I'm like, oh, you guys are thinking about the problem in a totally different angle, and I'm like, okay, I'm not where you're at, so I'm trying to find where you are, and then I'm trying to find where I need to go based on where you are, but also based on where my brain is going. Because like my brain is just still so basic. That's why. So it's mainly not your fault. It's mainly like my fault because it's like, oh, I'm not at your
your guys's, like, I guess, level of speed when you're thinking about problem solving. Which is basically like me having to train my brain a little bit more. So it's like that term when you're playing a video game and you're not great at it. Like, basically everyone's like saying, get good. And it's like, I'm trying. I think we can probably continue this next week, because it's already like 4 o'clock, so I will definitely try to pick this up next week. Let's see if there's anyone streaming today on Twitch. Thanks for putting it so nicely. No. It's like, the thing of it is that I'm surprised that all you guys are basically coming to my streams, and I view you guys as like, wow, you guys are already like brilliant in your own fields, or, you know, your own studies, and I'm like, wow, I'm so behind these people when it comes to like thinking about problems. I'm like, they think about these different tricks and these different ways of manipulating equations or trying to solve a math problem, and I'm like, whoa, like, the only thing I can remember is like stuff I've learned from the textbook. So I'm like, why isn't, like, I have to train my brain to actually get up to your guys' level when it comes to actually like looking at a problem and looking at it from different angles. So I mean, like, you know, like, I'm pretty sure that's why a lot of people are intimidated by math. Like, last stream I felt like, wow, like, I am not at the level that you guys are at. You get the perspectives from practice. Yeah, true. Like, I remember there was one problem that I saw, and it revolved a triangle, and then it revolved lines, like, I think an X line, like, within the triangle, and I think basically the problem is that find the length of one of the lines, and then when I saw that triangle, it wasn't a right triangle, it was like, I think, an obtuse triangle, and I was like, oh, I see, like, a lot of things, like the law of sine, the law of cosine in that thing. Of course, it didn't say, like, use the laws of cosine or sine to solve this triangle, but I saw that, like, when I saw the triangle. And you're comparing yourself to how you were yesterday versus others, etc. I think it's because, like, that's how I kind of, like, put myself, like, I guess, like, that's how I kind of, like, because, like, I think my ego is, like, kind of, like, tied to, like, loving mathematics and physics. So sometimes I don't want to put my self-worth into, like, having a love and affection for those things. So that's why sometimes you find me comparing myself a lot, and I try not to do that as often. But, like, also, like, I guess for me, I sometimes, like, compliment others by comparing to how far they came compared to me, which is probably also not great. If you get what I mean. I guess it's like, for me, it's like, it's just basically trying to remain humble. But also I don't want to detriment myself by just being in the process of being humble, if that makes any sense. Okay, guys, yeah, I really love this. I actually really love using, like, whatever they call this. I consider it a game. Like, I would say it's like a game to me. So I love this, like, math game that Sasha showed us. I'm definitely gonna play this, like, the next time I stream. So yeah, I think this is gonna, like, help me in my goals of, like, being able to learn how to do proofwriting a little bit more effectively, how to envision thinking about proofs. So I think that's what I'm enjoying about this, and it also is pretty fun because it allows me to look at it as not like, oh, I'm opening a textbook and I'm basically trying to prove to a professor that I can do academic work. It just feels as if, like, oh, this is something I love and I actually can engage with it in a very fun way, and it's very unique, I think. So thank you guys for joining me today. If you're lurking right now, you know, like, drop me a follow if you like math, physics, or you just want a productive stream to basically make yourself productive in front of your computer, because I know it's really hard, especially with people that are working remotely. Like, they need something to, like, basically pass the time. So first of all, if you want to check out my YouTube channel, in case you had to leave the stream early, You can subscribe to my YouTube channel. It also helps. And also, I think it will also, like, because we have this game with us, I think our streams are going to be a lot more fun. And also, if you would like to join our Discord server, you're more than happy to join our Discord server as well. I think the feedback loop that Lean offer you is pretty good for self-taught like you. Oh, thank you, Sascha. I really appreciate that. Yeah, so if you guys want to, you know, talk about math, talk about physics, or just, like, you know, share your knowledge with us, like, you know, whether it be your research or something, and you just feel like you need to rant about your research, like, because you're stuck on a problem or something, like, you know, you can basically, like, talk about all that stuff in our Discord if you like. I know, like, I'm trying to be more active on Discord because I noticed that, like, you know, we do have some people in there, but I feel like I'm not engaging enough with it. So I'm trying to think about how I can engage in the Discord server a bit more. So if you guys have any suggestions on that, please let me know. Because sometimes when I find resources on YouTube, I basically post them there to, like, you know, like, help each other out, as well as, like, I think this is very interesting to watch. And also, if you guys want to check out my gaming channel where I play games and stuff, you're more than happy to give me a follow on my Uncle Talks channel. That's where I just play video games, and I think tonight I'm gonna try to play Mecha Break, which is basically a game where you just pilot a Gundam, or in this case, pilot a giant robot. So I've been looking forward to the game, and I played a little bit of it, but I think it would be fun to stream. So if you want to join my Uncle Talks channel, you're more than happy to do so. And I think we're gonna do a raid today. We're probably gonna raid into... Oh, Don Does Math is streaming. Oh, he's playing a game, but I think we can give him a proper hello. So I will put the raid message for you guys. You're more than happy to copy and paste that. So we'll copy and paste that. And then we'll just commence the raid into Don's channel. Don Does Math. Okay. So I will put up the raid like so. Okay, guys, thank you for joining me today. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys on Don's channel. So take care, guys. Bye-bye.